Welcome to another tutorial of ProfLearn YouTube channel. In this video, we're going to look at IGCSE Edexcel Paper 1 Physics of June 2025. What were the key areas that were tested and what you are supposed to have known in the process of answering questions in this paper. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload an tutorial, you'll be notified. So diving in and getting started, the first area, students were supposed to have known the formula that is used to calculate average speed. So the formula that links average speed, distance moved, and time taken. And this is exactly what you are supposed to say. Part 2 or Roman 2 of the question, students were given the speed at which the object is moving, which is 2.8. And the time that object moved, which is around speed is 2.8 and the time is 3.5, and the student was supposed to calculate the distance traveled. So here, as a student, you are supposed to remember that average speed is distance over time. So which means that if you have this formula here, you can be able to create a triangle formula from there. And then you're going to say that from this, I can be able to say speed. Sorry, I'll just need to rearrange it a little bit here. I'll say speed is equals to distance over time. So which means that if I want to find distance is time, speed times time. So that's what you are supposed to remember at this given point. In question 2, you are supposed to draw an arrow to show the force of friction. Force of friction is going to be acting to the left. So friction force will be a force that is acting towards the left. And you are supposed to draw an arrow that is acting toward the left for you to show how friction is acting. Moving down, we are asked, explain how the force of friction. You are supposed to explain how the force of friction changes the velocity of the pack. Remember, friction force is acting to the left, which means that it's going to slow down this particular pack that is here. So we are to identify that frictional force decreases the velocity since it's acting the opposite direction to the pack's motion. And the concept or the part of astrophysics, in the part of astrophysics, students were given different orbits. We have orbit A, whereby there's an object Y and X here at the center, and you can see this could be the sun, and then this could be a planet orbiting around. And this one could be the orbit of a comet. We know orbit of a comet is quite elongated and the sun is squashed to one end of that. And then the student was supposed to complete the table by placing one thing for each of the following: Earth and the moon. Remember, the Earth is at the center, the moon orbit around it, and the orbit is usually circular. And this is the best to describe that. And then we have the sun and the comet. Then B is the correct one because the sun will be towards one end of the ellipse, elliptical orbit. The sun and the earth, A can also describe that best. And then type of force that causes object to orbit around another is gravitational force, the force of gravity. And that is exactly what students were supposed to have identified in that particular question. Moving to the next part here, we are told the table gives information about different stars. So this is now classification of stars. We are told that the table gives information about different stars in the same galaxy as the sun. Our galaxy where the sun is called the Milky Way galaxy. And now this is a question that made most students to cry. Explain how stars can be classified according to their color. Something that you need to remember is that color also tells you about the surface temperature of a star. If a star is blue-white, this is a very hot star, but if a star is red, yellow, these are cool stars. So which means that stars can be classified based by their color, because the color of a star indicates the surface temperature of that star. So color is directly proportional to how hot and how cold a star is. And then if you want to classify them, you can start from the coolest, which is Antares. We have Capella, which is yellow. Yeah, Capella. Yeah, it's Capella, yellow. Sirius B, and Vega being the hottest. So you are supposed to come up with that particular explanation. Describe the likely evolution of Antares. So we are going to see Antares in its evolutionary stage is at the red supergiant. If a star is at the red supergiant, it means this is a massive star. And if the star is massive, it means it's going to evolve. Is going to evolve. In the process of evolving, is going to so in this case, a red supergiant is a massive star, so which means that in the process of its evolution from the red supergiant, it can explode to become a supernova, which finally becomes a black hole or a neutron star, depending if it was massive. So if it was very massive star, it becomes a black hole. If it was just massive, more than the mass of the sun, it becomes a neutron star. Okay, so describe the likely evolution of Antares. This Antares explodes as a supernova. It becomes from a red supergiant, it becomes a supernova. After this, it collapses to form a neutron star. If it was very massive, it becomes a black hole. So whenever you are asked a question to do with evolution of stars, you need to consider evolution of stars. You need to consider what was the initial mass, and that mass is compared to the mass of the star. Describe what conditional information is needed to predict the next evolution stage of Vega. So if you look at Vega, is at the main sequence. So from here, from the main sequence, it can either become a red giant, a red giant, or a red supergiant. So if it was very massive, it becomes a red supergiant. If it was just massive, it becomes a red giant. Yeah, so which means the information we need to know, what was the initial mass of this Vega star in comparison with the mass of this the sun. So as a red, that's what I'm saying here, that the mass is needed so that we can be able to compare the mass with that of the sun, so that we know if it's a massive star, it's going to become a red supergiant. If it was a low mass star just as the sun, it becomes a red giant. And then a star that is a red giant, it evolves to become what? To become a white dwarf, and then finally it cools down to become a black dwarf. The question to do with electricity, we have an ammeter which measures current. We have a thermistor here, which is a type of resistor whose temperature depends on we have a thermistor whose resistance depends on the temperature of the surrounding, and then we have a fixed resistor here. And remember, if you want to measure the voltage of a component, you need to use a voltmeter, but it has to be connected parallel to the component. So this is the question that mostly asked. Maybe for instance, you may be asked, draw how a voltmeter should be connected in order to measure the voltage across the thermistor. So that is how you can connect it. So if you are given a question like that, don't hesitate to answer such a question. Let's move and see. Explain why the reading of the voltmeter is 2.1. So we understand that these two components here are in series. and which means that that voltage that is being supplied here is going to be shared to this. So if the voltage across the thermistor is 3.9, so if the voltage here is 3.9, it means this must be 2.1, so that if you add 3.9 plus 2.1 you get 6 volts. So we are going to say components are in series, so PD supplied store is shared between the thermistor and the resistor. So voltmeter, all the voltage reading here must be 6 minus 3.9, which is 2.1. And the event that you are asked to work out current, you are going to use this formula here. And remember that a triangle formula for that is V is equals I R. So meaning that if you are finding current is voltage over resistance, which we are going to use at that particular point. Okay. And if you're supposed to state the ammeter reading, remember current is the same throughout all the components in a series circuit, and that is why the current here is going to be still 0.072 and the ammeter reading. Calculate the resistance of the thermistor. Since we have the voltage as 3.9, the current is going to pass here is 0.0072. Then it means that we can be able to work out resistance using the formula V over R, and that is going to be 540 ohms. 540 ohms. The student observes that the voltmeter reading increases as the temperature of the room increases. Voltmeter reading increases as the temperature increases. So as temperature increases, it means that the resistance of the thermistor decreases. So meaning if voltage decreases, or rather as resistance decreases, then the potential drop, the PD across the thermistor, is going to go down. If the PD goes down, it means that there will be a larger share in this fixed resistor. So in that way, I've given a classical description on how you're supposed to respond to this question, whereby you're going to say as temperature increases, resistance of the thermistor decreases, and this causes the total resistance of the circuit to go down. So total resistance of the circuit is going to decrease, and the current in the circuit increases. So which means that since the resistor has fixed resistance, increase in current in the circuit is going to result to a larger potential drop across this resistor that we're having here, because anytime you want to calculate for instance PD across this, you are going to use PD across this is going to be the current in the circuit times the resistance. So if current increases and resistance here remains the same, then it means the PD or the voltmeter reading is going to be higher. So basically that's what you are going to say in that particular question. A student wants to use a circuit as a temperature measuring device, and they have this additional equipment. We have a large beaker, water of different temperatures, and the thermometer. Describe what measurements the student needs to take so that the circuit could be used as a temperature measuring device. So I responded in this particular question by saying place the thermistor and the thermometer in a large beaker of water. Heat the water to a range of different temperatures. Every time you are going to heat the water to a steady temperature, you are going to take the voltmeter reading. So you are going to have different around 6 sets of temperature reading and voltmeter reading, and then you plot a graph of voltage against temperature. Now, for instance, if you get a graph like this, and you want now to use as a temperature reading device, then you are going to use the circuit and read the voltage. Once you read the voltage, you come and identify a read of points, and then you can now measure, use the graph in order to find the temperature. So plot a graph against temperature. When using a circuit as a thermometer, the voltmeter reading will be taken, and then the corresponding temperature is read from the graph. Basically, that's what you are supposed to have said in this particular question. Question 4 was about nuclear reactions, and we are supposed to state what else is produced during a nuclear fission reaction. This is thermal energy is given out, and then we have a nuclear reactor. A nuclear reactor is down here. We have shield, which is going to prevent radiation from getting out. We have a coolant, of course, to cool, because there's a lot of thermal energy produced, so we need to cool. We have control rods, and then here you usually find graphite. So let's go and check the questions that are asked. We have control rods. Control rods are used to absorb excess neutrons, because if you reduce the number of neutrons in the reaction, then you are going to slow down the reaction. So control rods are used to absorb neutrons. And then we have moderators. Moderators are usually made of graphite, which slow down the neutrons. And then we have a question that was you were supposed to state what's meant by ionization. Ionization is ionization or ionizing radiation. Ionization is the removal of electrons from an atom. But ionizing radiation is a type of radiation which has enough energy to remove an electron from atoms to create or to form ions. Also, we learned that nuclear reactions are spontaneous and random processes. So spontaneous means that they are never affected by external conditions such as pressure and temperature. But also random, it means that this process, radioactivity process, is not predictable. You cannot be able to tell which atom is going, or which nuclei is going to decay next. Next, the question was testing about the purpose of shielding. Remember, shielding is made of thick lead and also it can be made of concrete, thick concrete. So this shielding, because we know there are a lot of radiation that are given out from this nuclear reactor. So the nuclear reactor has to have this shield made of thick lead or concrete so that it can be able to prevent the radiation from penetrating to the surrounding. Because we know these radiations are harmful, so the shields prevent the radiation from getting out. In the process, the people are protected against those radiations that are coming out. We have gamma radiations, which can penetrate thick lead but can be stopped when the lead is thick. So shield is made of thick lead or concrete, and this absorbs ionizing radiations emitted from the nuclear reactor. This radiation may be harmful because they may cause cancer. So shield reduces the radiation that reaches the people outside the reactor, reduces the amount of radiation that is getting out. So if you're new to ProfLearn YouTube channel, check in the description, there's a link for part 2. And also, if you're new here, consider subscribing so that anytime I'm going to out a tutorial, you'll be notified. See you in the next tutorial.